Hi, welcome once again to another class with the Moj Maths and Science. In today's class, we'll be looking critically at examples with quotient rule. Remember that in our last class, we said if y is equal to u over v, the y dx will be equal to v du dx minus u dv dx over v squared. Please be careful not to mix both of them together like I actually did caution in the last class. In case you missed that class, you can see a link here to our class on quotient rule. Now, let's start with question 1. If 1 says y is equals to sine x over x squared, here obviously my u is what you have at the top. That's sine x. And my v, and my v is equal to x squared. So that if my u is sine x, my du dx is cos x. If you differentiate sine, you get cos. If you differentiate cos, you get a negative sign. Please bear it in mind. In our next class, we will actually take more of trigonometry and you see how it works. But this is an introduction just for us to get familiar with it. And like I always say, if you are interested in mathematics at this level, please do not hesitate to subscribe to our channel. We will deliver more on this. Now, v is equals to x squared, so that dv dx is the same thing as what? 2x. Now let's substitute these values back into our formula. So that my dy dx is equals to v. My v is x squared into du dx. My du dx is cos x minus my u. My u is sine x. That's sine x into, and my dv dx is 2x. Everything over v squared. Remember my v is x squared. That's x squared all squared. Now, let's open up this expression. You see that this expression becomes x squared times cos x. That's x squared cos x minus 2x times sine x. 2x sine x over x squared all squared. That's x raised to power 4. Now I can still simplify this if I desire to, but for the sake of records, okay, let's simplify it. I have x here, I have x squared here, and I still have x at the bottom. So we can factorize and bring out one of the x. That becomes x into x cos x. That becomes x into x cos x minus 2 sine x over x raised to power 4. X gives away here, becomes 3 here. That's the same thing as x cos x minus 2 sine x over x raised to power 3. With that, we've been able to simplify that expression. So let's take the second example. In this example, we're given that y is equals to sine x over cos x. I said we'll be using quotient rule where if y is equals to u over v, my dy dx is the same thing as v du dx minus u dv dx over v squared. So that if u is equals to sine x, my du dx will be equals to cos x, and if v is equals to cos x, remember that our dv dx becomes minus sine x. Now with this, let me say this. Y is equal to sine x over cos x. What does this remind us? Sine x over cos x is the same thing as tan x. It reminds me of tan x. Let's continue. My dy dx, let's substitute in our modern equation. My v is cos x. It becomes cos x into my du dx is cos x. That's another cos x, a separate cos x on its own. Minus my u is sine x. And my dv dx is minus sine x. Minus sine x. Everything over v squared. Remember my v is cos x. That's cos squared x. So that your dy dx is equal to cos x times cos x. That's cos squared x. Minus times minus. That's plus. Sine x times sine x. That's what? Sine squared x plus sine squared x over cos squared x. Now let's remember from our trigonometry that cos squared x plus sine squared x is equal to what? 1. Now we'll still take our time to teach trigonometry. We'll teach trigonometry in full. If you are interested, please do not hesitate to subscribe to our channel. That way you'll get notified when we take such classes. It's still one of those classes we will take in full. Now cos squared x plus sine squared x is 1. So I can put 1 here over cos squared x. Now 1 over cos squared x, 1 over cos x from trigonometry is sec x. That means I can easily say my dy dx is equal to sec squared x. Now what does this imply? Remember we said that our y is equal to sine x over cos x, and this is the same thing as what? Tan x. That means anytime I have y is equal to tan x and I'm differentiating tan x, I will get what? Sec squared x. With this, we've tried our hands on quotient rule. In our next lesson, we'll try our hands on further examples relating to both quotient rule, product rule, function of a function, and also trigonometry in calculus. And later on, we would explain on trigonometry in full. Thank you, and have a nice day.